into account of that thing. So they thought to create this particular software in some language, and at that time one B language was there in AT&B lab, okay, in USA. So from this particular language, Dennis Ritchie and the few people over there, they created a C language, right? They removed some of the parts of this particular B language, and then they created a clean C structured programming language, that is C language. And then from this C language, they started to develop this particular software, okay. And finally, once they developed this particular software, they called this as an operating system. So the operating system was designed in somewhat in 1980s era, okay, when the C language was developed. C language was developed in 1980. So in that area only, after C language, they designed this particular operating system in that C language. And once this operating system was developed, and then whenever a new machine people used to buy, they used to first install this particular operating system, right? Because this used to take care of all those things which they require every now and then, right? So now we'll start with this particular C language, okay. Before we will move to this language, let's understand first few terms. Like, first we'll study what do you mean by algorithm. So just write the definition of the algorithm. It is a sequence of steps. It is sequence of steps sequence of steps to solve any particular problem. Sequence of steps to solve any particular problem. Sequence of steps to solve any particular problem. So algorithm is nothing but it is the steps, okay, where for example, if we have any problem, and we are deciding to solve that particular problem, so basically we will going to make the plans, right? What different steps we will going to carry out. So what should be the first step, what should be the second step, what should be the third step, right? What should be the end step, like that. It will be a sequence of steps. It should go in the sequence, okay. It should not be like if we will carry out the first step, then we can directly jump to the fifth step and then the ninth step, like that, okay. It should be the sequence of steps, right? So to solve any particular problem, we will list down the sequence of steps, and that is nothing but the algorithm. So let's take one simple example. Suppose so let's say suppose somebody is there at Dadar, okay, and he wants to go to, let's say, XI, right? So what will be the step? So I'm writing the algorithm for this particular problem, okay. Some student is there and he wants to go to XI from Dadar. So the first step I'm writing, step 1, I'm saying start, okay. Then the step number 2, so step number 2, let's say the student wants to go by cab, right? So book cab. Then step number 3, right? Give OTP and get inside. Then step number 4, after reaching XI, pay the bill, right? Then whatever steps, if you're remembering, right, it's up to you. A different sequence of steps, the way you plan, you can write the all the steps, right? And then finally you can get off that particular cab, and then you can stop it, right? So remember, the thing is, the first step will always be start and the last step will always be stop. In between, whatever sequence of steps you are performing, that you can write down in different steps. So in the exactly in the same way, we will going to write the algorithm. I think people are joining or Try to join from the Xavier ID always. Okay. Yeah. So like this, you will be writing the algorithm. So remember, algorithm is nothing but the sequence of steps to perform any particular task, right? This is simple example I took. For example, we wanted to go from Dada to Xi. Then the person can choose anything like cab or auto rickshaw, or let's say by train. Okay. He may choose anything, and then whatever he is choosing, depending on that, he may write the different sequence of steps. Now, let's take one problem. The question is, write algorithm for addition of two numbers. Okay, simple problem. Write algorithm for addition of two numbers. So again, algorithm is nothing but sequence of steps, right? So I'm writing the first step, start. First and last step, start and stop. Then step number two, now I want two numbers, right? I want two numbers first of all to take the addition. So to take two numbers, we should have some placeholder where we can store the numbers. So for example, if you are giving 7, so what I'm saying that I'll be storing that in X and Y. Okay. So for that purpose, here I am saying define X, Y. Okay. So I'm defining the place. I'm defining that that particular thing where I'll be storing this 5 and 7. So I'm saying define X, Y, and then step number 3, I'm saying input X and Y. Input X and Y. That means get the input of X and Y. So for example, if you are inserting 5, so 5 will be stored in X, and if you are giving 7 as the input, then 7 will be stored inside Y. So this is the idea. First of all, whatever number you want to take, first of all make the place for that particular thing to store, right? And then you can take the input. And after this, I can say step number 4, print X plus Y. Okay, I want to print X plus Y. I want to perform the addition of both the number, right? So we took X and we took Y, and then I am printing X plus Y. And then the final step, I am saying step number 5, stop. Right. So this is a simple algorithm for addition of two numbers. It's nothing but the sequence of steps, right? We are writing a sequence of steps. See, we are not doing in this, for example, let's say before defining this X and Y, or before taking the input, we are not directly printing the output, right? We are not directly saying X plus Y. So we need to go in sequence wise. Every step we need to perform properly. So till here, whether everything is clear, all of you, algorithm is clear. This is the meaning of algorithm. So whether all of you understood, you can comment also. You can write that in the chat box, and if you have any doubt, you can ask.
Yes, sir.
Yeah. So I'm just trying to explain
Yes,
this
sir.
yeah, this concept with very simple example, so that at least, I mean, you will going to remember it, and then we can perform the difficult task. Okay. But the main idea is you should remember this, and you should understand how actually we are doing this. Okay. Now for the same thing, what we will do, for the same thing, now we will try to understand what we mean by flow chart. Okay. So we will going to draw the flow chart for the same problem, like addition of two numbers. So let's first try to understand what we mean by flow chart. Remember, algorithm means what? So whenever any problem is given to you, okay, first of all you will going to do what? You will going to write the algorithm, and then after that you will draw the flow chart. So flowchart is just like a graphical thing where you'll be drawing certain thing, and this algorithm is nothing but in the text you are writing. Okay, so it's in the text form. You are writing the sequence of steps. But if you really want to represent something, right, you can draw it, and you can draw the representation, right, and you can show to your superiors and all, right. So if any problem is given, you can draw different shapes. In that, you can try to solve the problem with the different steps. Now, for solving with the help of flow chart, there are some shapes which are standardized, right, all over the world, that we supposed to use these shapes only. Otherwise what happens, right, a few company will choose circle, few company will choose rectangle for some purposes, right. And then it was not happening in a standard way, right. So people decided everybody will follow some one particular shape for performing some particular task only, right. It's not that I am taking the circle and you will be taking the rectangle. So they decided, and then they came out with one particular standard format, right. So you will have to remember this. I'm just drawing and I'll show you the first shape. So here I'm writing shape and the purpose. So this is a oval shape. Okay. Oval shape. Draw properly. I'm not able to draw properly. Okay, like this oval shape. So this is for start and stop. Okay, we saw both the steps. The first step is start. So whenever you want to write start, you can always draw first, like this oval shape, and in this you can write start. Yeah, or for stop also you can draw oval shape and you can write stop. So first shape is what? Oval shape. The second is like this. Okay, these two lines are sorry, like this parallelogram, where these two lines are parallel and these two lines are parallel, right. So in this, you will be taking the inputs. Okay, if you want to take the inputs, you can take the inputs. So for taking inputs, or if you want to print anything, so for printing purpose, okay, or displaying, printing or display. So remember, this parallelogram you will be using for taking the inputs or displaying the outputs. Okay, or outputs. Then the third one is rectangle. So if you're performing any operation, okay, the rectangle is for operation. For example, here we are doing what? X plus y. So x plus y will be doing in this particular rectangle. Whatever operation you will going to perform, you can always write in a rectangle shape. Okay. So again, I'm revising the oval shape for start and stop. The parallelogram shape, okay, this is for what? Taking inputs or displaying the output for printing purpose. You can use this parallelogram. Then the rectangle shape is there for performing any operation, performing any task. Then after that, the fourth one is, you can use these arrows. Different types of arrows are available for, these are called as connecting arrows for connection purpose. Okay, and connecting arrows for connection purpose. And it will also show you the flow of your program, right, where actually your program is flowing in which particular direction. So with the help of arrow, we can come to know. So there are four types of these arrows. And then we have this kind of, okay, structure, where we can have the decision making. So decision making we can have in this. For example, I can write in this way. So this is called a diamond. Okay, diamond shape. So let's say I'm writing like this. If A is greater than B? Okay, I'm asking. So we can have the answer like yes, or we can have the answer like no. So if you see here, this is a decision making where I'm trying to make the decision, and there are two outputs. One output is possible, either yes or no, right? So depending on yes, if yes is there, then I'll be performing certain tasks. If no is there, then I'll be performing certain tasks. So here we can make the decisions, yes or no, right? This is called as two-way branching. Two-way branching. Two-way branching. Similarly, I can have let's say I'm writing compare A and B. So I can have here, for example, A equal to B, or A greater than B, or I can have A less than B. Right? So three possibilities are possible. This is called a three-way branching. Three-way branching. Okay. Then I can have multi-way branching also. For example, I'm writing like this, and I'm saying A is equal to what? So based on A is equal to what, I can make multiple decisions, right? So let's say, suppose I'm saying if A is equal to 1, then we will going to perform this task. If A is equal to 2, then we will perform this task. If A is equal to 3, we will perform this task, right? Like this. So this is called as multi-way branching. This is what multi-way branching. Multi-way branching. So what I was explaining, there is a diamond shape where you can write the decision making stuff, right? It can be two-way, three-way, multiple way, okay, branching. So that depends on your code, how you are writing that. Again, I'm revising. Oval shape where we can write the start stop. Parallelogram where we can take the inputs, we can print the output, okay. Rectangle is there for performing operation. Arrows we are having for connection purpose, right, which will also show you the flow of your program. Then the diamond shape, which we can take some decisions, right, and decisions can be of different types, that depends on our program. And then we also have this kind of element. This is called as connecting circles, right? For example, what happens, suppose in the exam, if you are writing if you're drawing any flowchart, right, and this is the end of your graph. So for example, here here we are having rectangle, and after that there is no space, so we can draw a circle over there. In that, let's say we can mark any symbol. Let's say if I'm writing A, so on the next page we can start like this again, and then after that you can start drawing. So it's like we are doing the continuation on the next page, okay, from this particular thing. So from the same part, we are doing the continuation on the next page. So all of you just make a note of all these things, okay. If you have any doubt, you can ask me. In the next lecture, I want everybody to join by your Xavier ID. Otherwise, I will not take you in. Okay. So remember this. Before that, only we can sort out whatever issues you are having with your mail, right? And try to join in the classroom. So whether all of you understood this flowchart?
Yes, sir.
Yes,
Okay.
sir.
Okay. So now what I'll do, I'll just try to solve that particular problem. Okay. So addition of two numbers with the help of this flowchart. So let's try to draw. So I'll draw over here only. See, the first step is what? First step is what? Start. So I'm drawing a oval shape and I'm saying start. Then with the help of arrows, define. So define or input output you can take inside your parallelogram. So here I am saying define xy input xy. Okay. And then now I want to perform addition. So I am saying in rectangle I can I can define one more variable. Let's say uh, a result. Okay. So that in the result I can have over here result. Inside this I can have x plus y, and then after this I want to print. So for printing I can say print x plus y, sorry, print result, and then after this oval shape stop. See, again I'm drawing over here. First step oval shape start. Next input. Okay. So I'm define x y, and then let's say sum xy sum, and then I'm saying input x y, and then the next step I want to perform the addition or sum. So in rectangle sum x plus y, and then I want to print this, print sum, and after this stop. So this is how we can write the algorithm, and we can draw the flow chart. Now I'm giving you one problem. You take two numbers, okay, two numbers, and write an algorithm and draw the flow chart for determining the greatest of two numbers. Okay? Greatest of two numbers. So for example, you will take xy, and at the end you're supposed to tell me whether x is greater or y is greater. Okay. take 5 minutes and write the algorithm for this one and draw the flowchart also. Okay, done all of you? So you can write. So let's write the algorithm first. So the first step, start, right? So you can draw a oval shape for this one, start, right? Step number two, we can say here, define x, y, and input x, y. Okay. Then step number three, if x is greater, you can write like this: if x is greater than y, then print. So what you can do, you can first check whether both are equal or not, right? So there might be the case that both the numbers are equal. So if they are equal at the start only, you can print they are equal. You can say if x is equal to y, then print both are equal. Step number four, if x is greater than y, then print x. Step number 5, if y is greater than x, then print y, and last step, stop. Okay. So in the same way, you can draw the flowchart also. So for example, this is my start stop. So first start, then define x, y, input x, y. Okay. Now I can take the decision. So this diamond shape, I'm saying compare x and y. Now three-way branching I can take. So this I can take as x is equal to y. This is x is greater than y, and this is y greater than x. So if this is the case, then I'll say what I'll print. I'll print x. Print both are equal. Print both are equal. Okay. And this will go like this. Here, if this is the case, then we will print x is greater. Okay. Print x is greater. It will come like this. If this is the case, then we will print y is greater. Y is greater. I'll attach over here. Similarly, this will come, and this I will attach here. And finally, whatever is the case, it will terminate. So stop. Okay. So like this, we can write. We can draw the flow chart. Start, then the define input output, and then you can compare, and three-way branching you can make, and then finally. So always remember, a flowchart must terminate. Okay, must end at one particular point. So uh, here we are comparing. If this is the case, then it will go here, and here we are attaching. Then if straight away it will go like this, y is greater, okay, or else it can go in this particular direction, x is greater than y, and then it will end over here, finally stop. So whether all of you understood this?
Yeah. Yes, sir.
Okay. So again, let me revise what we did. We saw algorithm, okay, and then flowchart. Algorithm, it's a written form or text form, okay, a written form or text form. This is graphical form. This is graphical form. Algorithm is nothing but sequence of steps, okay, sequence of steps to solve any problems. Flowchart is nothing. This is also sequence of steps, but this we, I mean, it's the same algorithm we represent in terms of flowchart, but with the help of graphical shapes. Okay, so we have the standard shapes for this flowchart, like oval shape, parallelogram, then rectangle, then diamond. Okay, for decision making, the rectangle for doing the operation. So you will have to remember that thing, the connecting lines, and then at the end one connector is there. Okay. In the last lecture we saw what? In the last lecture we saw machine language, right? Machine language. Then we saw assembly language. Assembly language. So machine language is nothing but zeros and one stream. Okay, zeros and one stream, which computer understands. Assembly language is nothing but small symbolic codes. Small symbolic codes, right? Which are a little bit easier to write the program. We can understand it, like the codes will be written in this particular format: add, subtract. So these are small symbolic codes. But computer will not going to understand. So we will require an assembler, okay? Assembler which will convert this assembly code into a binary code. Then computer will understand. Now C language is what? C language is a high level language. Okay. C language is a high level language. High level language means it will be written in English kind of words, okay, English kind of statements. It's a high level language, but it has the special capability to talk to the hardware also, right? So it can easily talk to the low level languages. Low level languages is nothing but your assembly language and machine language, okay? And C language is considered as a high level language. So remember this, C is what? High level language. So in many books you will find that it's written C is a middle level language, but there is nothing. I mean, in this computer world, either it will be zero or one. Okay, it should be in the binary format. There is nothing in between. So either it will be a low level language or a high level language. Remember, the C is a high level language, but yes, it has one special feature. It can also communicate with the hardware directly. Okay, that's the reason we write the device driver kind of program with the help of C language. Okay. So now from the next lecture, what we will do, we will start with the C language character set and all its